Hey class, so in this PowerPoint we're going to cover batteries. Okay, this is the beginning of batteries. So we're just going to cover really the theory and how they work, the operation and the function. Okay, so first thing, what is the purpose of a battery? So there's a couple things. These are the main two. There may be more than this, but these are the main primary two if we just break it down more simply. Okay, so the purpose of the battery: store electricity when demand exceeds alternator output. So the alternator is constantly charging the battery when the vehicle is on, say the engine has to be running. As the electricity is being removed from the battery, the alternator is charging it. Okay. Sometimes the uh, demand on the alternator is high enough to where the battery and the alternator kind of work together in a sense to be able to produce enough electricity to be able to power the vehicle. And usually this would happen, say, like if you're towing something at night or if you're going up a hill at night. The reason I say at night because all your accessories are on, and maybe even on a hot day when the air conditioning is on. So it's at night or evening time, your lights are on. You're going up a hill, which means there's a high engine load. If you're on a truck, you may be towing something, and then also you have the air conditioning on as well, which is going to draw a lot of electricity. So if in all those instances if that happens, the demand of the alternator could be too much. So the battery could help assist in that instance. Or again, the if you want to look at it the other way, where the alternator is charging the battery needs to be charged even more, so to say. Okay. The other power source. So we're gonna is going to be a power source for starting. So when the vehicle starts, we need electricity to get the starter motor to turn over so it can turn the engine, so it can rotate the engine. And the power source is the battery, and that's a storage unit for electricity. Okay, so that's what our battery does. It's really there for starting, and then once the vehicle starts, then the alternator kind of takes over in a sense because it's charging the battery consistently. Okay. Read through some of these. None of these are highlighted. But why are batteries important? I mean, obviously, I think the main reason is to run all the electrical components in our vehicle. We have a lot of electrical components now, and we need a good power source to be able to run all the electrical components. One thing down here, if the battery is weak or discharged, it could give a false test to the alternator. So before you do any electrical diagnosis on any vehicle, you have to make sure that we have a good battery to start with. The battery has to be good. So you check that first. It's a quick check. They make these little handheld conductance battery type testers. You can buy them at AutoZone or you can buy them through Matco or Snap-on. They're not they're usually not too expensive if you just get a decent one, maybe like $100, $150. They do make some really advanced ones that cost thousands of dollars. You wouldn't need that in your own toolbox. The shop would have that, but a small handheld battery tester, might be okay for you to purchase if you're testing a lot of batteries, or if that you may want to do that or go the electrical path in the future. Okay. But we want to make sure the battery is good because if we test the alternator before we test the battery and it gives us a bad reading on the alternator, we could actually have a bad battery, not the bad alternator. So we start with the battery first. Okay. Most batteries nowadays are maintenance free. I'm not gonna say all of them, but a lot of the newer ones are. Maintenance free means that we do not put water in the batteries. Okay. Older batteries, we used to have to be able to take off the caps. So this picture over here, I circled the two holes there where it's labeled as a valve. Um, there's usually a cap there, and that cap we would pop off and we would put water in the battery. We try to put distilled water in the battery. Okay. We don't really do that anymore unless the battery allows it to do it. The way we can tell is if those caps on top of the battery are really, really easy to pop off. So if you can just take a little pocket screwdriver, or even a pin and pop off that cap, then and you can look down there and see the cells and the water, then you can add water to it if needed. Okay. If you can't do that real easily, so some of them look like they are require maintenance, but you go and you try to take the cap off and it doesn't pop off because it's glued on there. So don't try and take it off. Okay. Those are maintenance free. That means we don't add water, we don't add anything to it. When we buy it, we put it in the car, and then it lasts for however long it lasts. Hopefully batteries will last 4 years, 5 years. Some I've seen like 6 years. That's a long time. But for the average, I've seen about 5 years myself from my experiences. Okay. What couple things I do want to point out here is that a battery is 6 cells. Okay. And each cell does have a positive and a negative plate. If you look at the picture here, you'll see that the positive plates are identified, one area, and the negative plates are identified in the other area. But what we have is we will have a positive, then a negative, a positive, then a negative, positive, then negative, and so on. Okay. The battery cells, which we will get to, but there are 6 of them. Okay. There has to be 6. If we do some basic math, we've always said that the battery voltage is 12 volts. So if we have 6 cells and 12 volts of a battery, how many volts is each cell? Okay. If you took 12 and divided by 6, that would give us roughly 2. There's a little more exact number, which we'll get to, but each cell is roughly 2 volts. Okay. And we'll get to the exact number in just a minute. Now the plates inside of the battery. Okay, so the battery is just a plastic box. We put lead, 2 different types of lead inside of that box. Then we put water and sulfuric acid. By doing this, we create a chemical reaction. So the batteries use electrochemistry is what they use, electrochemical, electrical generation, you can say. Okay. The positive plates are lead dioxide and the negative plates are just lead. All right. So it's 2 different types of lead. They're both lead, but they're just different types of lead. Kind of like we can have different types of steel or different types of aluminum, but they're still aluminum or still steel. Okay. The positive plates, again, lead dioxide, and negative plates are lead. We take those 2 types of different of leads, we put them in the plastic box, we seal it, but before we seal it, we put sulfuric acid and water inside of it. Okay. And by doing this, we cause a chemical reaction. So there's chemistry going on inside of it, a chemical reaction, and electricity is created. It's just generated by putting those things in that box, in that plastic box, which is called the battery. Okay. So this chemical reaction. So I want to make sure everyone's aware of that. If we wanted to do this, at home, we could. So what this picture shows is that we have lemons. Okay. And we have nails that are put into the lemons, and then we have wires connecting those nails together with a little LED at one end of them. See how they're wired in series? Now, if we did do this, the way it works is we need the nails. They have to be some sort of metal, so steel. Okay. That is a conductor of electricity. We stick them inside of the lemons. Why do lemons work? If we think about it, lemons are very acidic. So we can use a lemon, we can use an orange, a grapefruit. So all those are very acidic. They have acid inside of them. Just like when we put in a battery, we have water and sulfuric acid. That's what's called the electrolyte inside of a battery. So we take a nail, we put it inside of a lemon, which is acidic, causes a chemical reaction. We wire them together and wire it to a little small LED, which is a light emitting diode, just a basic little light. And electricity is created. It's generated by doing this. I mean, not a lot of electricity, but enough to light up that little light for it to work for a little while. Okay. But this just shows you the concept of how electricity can be created and is created through chemical reactions. The plate that we're looking at here. So this plate here that we're looking at right here, if you notice, it has all these honeycomb type of patterns here. Okay. The plates have to be uh, they have to be hollow in a sense or have this pattern, because when the plates are stuck inside of the plastic box and they're all wired together or pressed together, the electrolyte, which is again sulfuric acid and water, has to be able to flow through all of them to cause that chemical reaction. So it has to get to the whole plate. It can't be cordoned off. So if the plate was solid, it wouldn't be able to get through. Think of it sloshing around inside. It doesn't slosh inside, but think of it as going through that way. Water, um, sulfuric acid that is suspended in water is going to follow the path of least resistance, just like water does. So it has to go through the plates. So that's why the plates are in that grid type of format. Okay. And again, this is all within the box, within the plastic box that we see known as a battery. The plates, again, we have a negative plates and we have positive plates, and they are separated. We do not want them to physically touch. That's what these separators are for in the middle. If we look in the picture on the left here, the separators separate the negative from the positive. We don't want them to touch. We want them to be wired in series, meaning that they're wired together, but we don't want them to touch, because if they touch, then we have a short circuit in the battery, and that'll cause the battery to go bad. Then we'll lose um, roughly 2 volts if two cells touch. We'll lose approximately 2 to 4 volts, and that's not good. If we look at the other picture on the other side over here on the right side, this just shows them how they are kind of labeled, and this is a cell, or not labeled, but how they're placed inside the box, and how they're kind of welded together, or soldered together, so to say. And this shows a cell right here. So this is one cell. If we look at the box here, one cell. And then if you notice here too, also, I'm going to circle this. So notice where I circled, that is kind of soldered together. That connects the one cell to the other, but they're not touching. Okay, we have the separators in between. So that way things are not touching. Okay, and again, the plates are all have that honeycomb pattern. So that way so the electrolyte can go through all the plates. Now, let's be a little bit more exact on the plates, on the voltage of the plates. They're exactly 2.1 volts. Okay, so we're going to be a little more exact now. So batteries are not 12 volts, but they are in fact 12.6. They are not 12.5. They are not 12.7. They are 12.6. If we want to be even more exact, they are 12.62. Okay, but we don't have to go out to that third decimal, but they are 12.6 volts. Okay. So second decimal place, we do not have to go out to that. So we're really just going to say that they are 12.6. Okay. We have been saying up to this point that they're 12, but in reality is 12.6, and that does matter. And I'll show you why it matters in a minute, because you'll notice that the voltage, as it drops, it goes down really fast, the percentage of charge, as it's related to the amount of voltage. And here we go. So a fully charged battery, 12.6, which we just said, which is perfect. That's what we want all of our batteries to be. If you were to go outside and check your battery in your car right now, and your car's been sitting there for, say, an hour, 2 hours, it should read 12.6. It should not read 12.5. It should not read 12.7. If there's an overcharge on it because you had your car running, so your alternator was on, then there would be an overcharge. That's normal. You can just turn the headlights on or something, or radio on, and that'll bring the voltage down to 12.6, and it should remain steady there as long as your battery is good. So anyone on any car, if we go out and we test the battery and the battery is good and the car hasn't been driven, we test in the morning, it should read 12.6. Okay, that's 100% charge as long as the battery is good. As it drops only 2.2 volts, you notice the percentage goes down really, really fast. So 12.4 is 75%, 12.2 is 50%, 12.0 is 25%. So it goes down really, really fast. So if you have a battery that is under 12 volts, you're under 25% charge, and it may not start the vehicle at that point. Okay. If you ever notice that the way to notice that your battery is getting low is how your car starts. So you get out and you put the key in or you push the button. If it starts very slow, so a slow cranking engine is an indication of a discharged or bad battery. So you want to check your battery if it's slow cranking. Okay. If it doesn't start at all, so you go outside and you put the key in or you push the button and nothing happens, there's a click and like the engine doesn't even turn over, that's not your battery. That's usually traditionally your starter or something else, maybe a sensor. But if the battery is going bad, the engine will still crank, but it'll just crank really slow. Okay. And it may start, it may not. It'll depend on the temperature outside. Temperature affects batteries a lot. And we'll get to that in the diagnosis portion of it. This is just a little bit of FYI. Go ahead and write this down or take note of it. When batteries do get discharged, so remember, there's a chemical reaction going on. So when batteries are discharged, they release chemicals. There's what do you call, like little, it looks like a white foam almost, or I don't know how to describe it, but like a on the battery posts, there's sometimes this discharge that comes from the battery inside, and that's indicative of An overcharged or overused battery, or just older battery, where the chemicals from the inside kind of like they're becoming gases and they want to get out. Okay. So as the battery is being used over time, they want to come out, the gases that are stuck inside of it, and they want to come out through the posts. So they'll come out through the post, through the positive post and the negative post. So that's the weakest point, where the metal posts are connected to the plastic battery. And so then when it comes in contact with the air, then that's when you'll have that little form of discharge or white um, substance. It kind of looks like foam, or like dish soap that's been like sudded types of soap. It'll look like that sometimes. Okay, kind of sometimes you can kill it with baking soda too. Um, but yeah, we have battery cleaners that we use, and that's what we clean that stuff with. But again, the plates inside too, they start to change and they start to become harder too as well over time. Because lead naturally, if you know anything about lead, lead is actually a very soft material. If you touch it, it's soft. Okay. Obviously, if you touch it, make sure you wash your hands before you touch anything else. But if you touch the lead is soft. I don't recommend going inside the battery and touching it because you'll burn yourself to the acid. But if we just had a piece of lead around, then we could just touch it, and it's a soft metal. You can bend it, you can break it relatively easily compared to, like, say, steel or aluminum. But the thing is, over time, as the batteries are being used, the sulfuric acid within the battery will be absorbed into the lead, because the lead is a soft metal. So it's going to eventually be absorbed, and the plates start to harden. And that's what really kills the battery over time. Okay. That's why our lead acid batteries, our water based lead acid batteries, which we're talking about here, really only last about 5 years on average. Maybe a little more, maybe a little less. But that's why over time, the plates inside are going to harden, and they're not going to be able to absorb as much of that sulfuric acid anymore as they used to when they were new. One thing, there's more of a definition here, a specific gravity. So if anyone knows anything about, say, medical things, or how should we say, it was in the medical field, or knows a doctor or knows a nurse or someone, they may have mentioned specific gravity. Specific gravity just means how dense something is in relation to water. Okay. Water is one, so that's like in the middle. Anything that's more dense or less dense is higher or lower number. So more dense is a higher number, less dense is a lower number. Okay. So the sulfuric acid mixture, the electrolyte mixture within our battery, is traditionally higher. Okay. If a fully charged battery is traditionally right about 1.265 specific gravity, meaning it is 1.265 times more dense than water, so to say. Okay. And that's really all I would that's really all I would want you to remember or understand. And that's what we're calling a fully charged battery. Okay. We don't really do this test anymore. This is more for FYI, in case it's on the quiz or anything like that. But the specific gravity, yeah, we don't really test anymore for that. We used to at one time, but not anymore. We just use the electronic testers, and it's easy to do. But this is one way to check it. You would need that electrolyte gauge, or specific specific gravity gauge. You would need that. Okay, it looks like a turkey baster, so to say, and you would suck up some of the water from the battery, and then the gauge would tell you kind of where it's at. All right. A couple things here. I think this is more common sense here. Battery should have hold downs. If your battery does not have a hold down, make sure you find one and put one on. Okay, battery should not be sloshing around in the car. They should be held down, rather and being rather stable. A sulfated battery. This is what a sulfated battery means. Meaning that, well, we talked about it earlier, but the plates start to get hard inside. They harden. Lead is traditionally a soft metal, but as it absorbs the electrolyte over time, remember we're talking about pressure, time, and heat, all these things going on over time. The plates will start to sulfate or harden in a sense, and that's what we're looking at here. And this is that like white residue I was kind of mentioning earlier too, that will come out from the terminals too, and you'll see that on the terminals sometimes. Okay, as the battery starts to age and get old, it can also happen due to overcharging. Now here's a couple. Here, these are the three. I'm just going to bring them all up. So the three ratings that are on most batteries. I don't want to say all batteries, but most. Okay. Or you can find it. The CCA, I'm circling it here, and I'm going to circle it on the picture. The CCA is going to be on every battery. That's the one that is common. That's the one we use the most. I want you to make sure you look at these two. So the CA, which is cranking amps, refers to the number of amps that can be supplied to the battery at 32 degrees Fahrenheit. So 32 degrees. That's very important because 32 degrees is 0 degrees Celsius, which is freezing. That's where the point where water freezes at 32 degrees Fahrenheit. So which means that when this rating here, so we have 1,000. So we're just using this battery as an example here. You can go look at your own battery, your own car to find examples, or any battery, on any car to find an example. But the cranking amps at 0 degrees, it was tested at 0 degrees, or 32 degrees Fahrenheit. Let's go with, depends on how you look at it. And you'll get 1,000 cranking amps. So that's really good. This is a good battery. This is a big battery, probably out of like a big truck or a diesel truck or something. Because most cars are around for the CA, they're around like say 700, maybe 600, 700, 800, somewhere in that range. Okay. Now, if we go to the CCA, which is cold cranking amps, that is measured at 0 degrees Fahrenheit. So we'll get in this battery 900 cranking amps at 0 degrees Fahrenheit, which is negative 18 degrees Celsius. So it's really cold. It is below zero, obviously. As far as Celsius goes, it's below freezing, I should say. Okay. And if this battery is rated at that roughly. So you'll get 900 cranking amps at negative 18 degrees Celsius or 0 degrees Fahrenheit. The last rating is your reserve capacity. So reserve capacity has to do with time and then in minutes. So what this means is that if you're driving down the road and all of a sudden your alternator breaks, you have an engine failure, you have some sort of failure that destroys your alternator, and your battery is just the only thing powering your vehicle. The RC, or reserve capacity, means that you're going to have roughly 100 minutes in this instance. It could be less, could be 60 minutes, could be 50, could be 40, whatever the number is. It's the amount of minutes that you get until the battery's dead, until it won't power the vehicle anymore. Obviously, this is going to change if you have the radio on, if you have your lights on, if you're going uphill, downhill. There's going to be a lot of variables, but that's roughly how much time you have until your battery's dead if you're to lose your alternator in some way, if you're driving down the road. Okay. So that's the RC, reserve capacity. Not all batteries are going to list all three of them. They are going to list the CCA, but they may not list the CA or RC. Okay. So if you go look on your battery, you'll have the CCA, but you may not have the other two. You may just have one or none. Now, there are new types of batteries, the AGM batteries, which stands for absorbent glass mat. So instead of having our traditional water that is inside of the battery that kind of sloshes around, and some batteries you can add water as it evaporates over time, our deep cycle / absorbent glass mat batteries, AGMs, they are completely sealed, and instead of using water, like a liquid electrolyte inside, they use a gel like a gel material, I should say. So they'll use a gel that they'll paste onto the plates, and that gel is the electrolyte. So it has the acid in there. Instead of using water, they'll use the gel and acid, and that gel will paste onto the plates. And so what that does is that allows you. So here's a picture of one that allows you to put them in different formats. So you don't have the rectangle cells anymore. You have cells that are like more in circles. They're wrapped, like as we see in the picture here, in a spiral. Then they're connected together. And then the other good thing about these is, since they're not serviceable, you can't put water in them. You don't need to put water because it's a gel. You can mount them in any direction, in any position you want. You can mount them upside down if you wanted to. And because again, there's nothing sloshing around inside of it. There's no water inside of it. It's just a gel. So that's the good thing about these. The bad thing is they're very expensive. So Optima batteries, or batteries that are AGMs, are usually, I mean, nowadays we're looking over 250, over $300 easily, maybe $400, maybe even 500 in some vehicles. So they're very expensive nowadays, and the prices are just going to go up and up. Okay, battery charging. So just a little note here. Make sure you write that down. That might be on a quiz or something. But we're going to charge batteries. So the main thing about when we do charge a battery, we have to know that there may be a surface charge on it. if we put a meter on it and we look at it and it's over 12.6, then that's a surface charge. If it's under 12.6, that means it's undercharged. If it's exactly 12.6, then we're good. We don't need a charge. So when we charge a battery, though, we overcharge it. Okay. We can't undercharge. We can't charge it at 12.5 and expect it to get to 12.6. We have to charge it at 13. And then when it gets to 12.6, then we shut it off. Or we put on the timer or something. Okay. You can overcharge it, and over time it'll come back. You don't want to overcharge it too much. You don't want to charge it at like 18 volts. That's way too much. But you can charge a battery. Most alternators charge batteries at around 14 to 15 volts, and that's okay. That's fine. We don't want to go too much beyond that, though. Okay. Then the last couple things. So there's only 3 more slides here. I'm just going to bring up all the bullet points. Make sure you write these down. Understand them. This just shows you about how we're going to jump a car. So if you use a jumper box, the jumper box is easy. What is pictured here, you take the red lead, you put it on the red terminal on the power side. You take the black lead, you put it on the black terminal on the ground side of the battery itself, on the actual physical battery. You could put the ground lead on the engine if you want. That's fine. But obviously the red has to go on the power of the battery. Okay. And then you start the car. For a vehicle, if you're going to jump a car with jumper cables, there's a little bit different recommendation. I mean, you could do it the same way. I've done it the same way. It hasn't hurt anything. The textbook way, so to say, is that you want to put the negative terminal on the engine ground, not on the battery ground. Okay. Meaning you clamp it to the engine, any metal part of the engine. Okay. And then that is your ground. So you're okay with that. Okay. But again, just write these down and make sure you have them with you when you take the quiz. So this conductance tester, this one here on the left side, I'm gonna circle it real quick. So this is the tester that I mentioned earlier that may be, that you may want to purchase at one point. It's not required at all. I'm not saying that, but if you're testing a lot of batteries, or you're working in electrical, it may be a good investment for you to be able to have that instead of going and trying to find the one in the shop all the time. Because these are the ones that are not too expensive. So this one's around, I would estimate around $250, $300 because it is from Matco. The one here on the right, this is an old VAT tester, voltage amperage tester. We don't really use these VAT testers as much anymore. They're not really needed because they would put loads on the alternators, and that could destroy some alternators, some batteries, and electronics in the car. So we don't really use these that much. But these testers, you may find them, or you may see them in a shop, and they can test your battery and your alternator and even your starter as well. But they are more expensive, so this would be a couple $1,000s, and you don't want to buy that and keep that in your toolbox. So that's not really necessary. And plus, it won't even fit. Okay, and the last thing I want to mention is group size, battery group size. So all batteries have a group size. The group size refers to the physical dimensions of the battery and the placements of the battery posts. So on some batteries, like General Motors, if you drive a Chevy or GMC or Cadillac, the battery they may be on the front. So the battery posts may be on the front. So you have like screws where you screw into the post into the front of the battery. On other batteries, like when I worked at Toyota, the batteries were on top. The posts were on top of the battery, and we just we put the cables onto the posts that were located on top. Okay, and they can be on top on the left side, they can be on top on the right side, they can be diagonal. The post can be the other diagonal. So the post can be in different locations, and they can be opposite, to where your power's on the left and your ground's on the right, or your ground's on the left and your power's on the right. Okay. And then the physical dimension. So what is the height, the width, and the length of the battery? Okay. And then the group, there's a number and a letter that is assigned to that. So you look up top on this picture here. This is just a graph, but 21 is a group size, 24, 27, 30H, 8D. So all those are different group sizes. There's a chart that you can go by. This is a website you could go to, but if you can just really Google battery group size and then type in your year, make, and model, and then it'll give you the group size of the battery pretty easily. Okay. But that's what the group size refers to, the physical dimensions and the location of the battery posts. Okay. And not all manufacturers use exactly the same on all their cars. They do change. And some of the group sizes can be used on different makes and different vehicles. So like maybe a Chevy Traverse and a Honda Accord, I'm just making things up, could use the same battery, same group size battery, right? They could. I'm not saying they do, but that could be an example. Or a Chevy Silverado and a Ford F-150, even though they are similar types of vehicles, they can use completely different group size batteries. Okay. So that'll be the end here of batteries. So again, reach out to me if you have any questions as always, and take care. Thank you very much.